Pozdrav svima. Hvala vam što ste došli. Sve će biti zapravo na engleskom jeziku, tako da nadam se da to neće biti problem, jer imamo uvijek i neke strane speakere. So, thank you all for coming. It's always nice to see familiar faces and especially the new faces that are coming into blockchain space and meeting our community here. So this is the second BUIDL meetup. You can join our meetup group if you want to subscribe to our updates and just discuss there, meet other people, because that's what the community is for, to share knowledge between each other, and hopefully will grow even more in the following time. BUIDL is co-organized by UBIC, that's Union for Blockchain and Cryptocurrency in Croatia. It was created to push some regulations with our country regarding cryptocurrencies, and now it's also gathering like-minded communities that want to push forward the adoption. Well, first of all, I want to mention some of our sponsors that helped us make those meetups. ABC Tech, they are a company that's focused on developing fintech solutions, and lately their banking solution, Leonus, has been nominated in New York on Finovate Awards as the best blockchain solution in fintech. So that's what they do. MythX is a security analyzer. Our speaker, Bernhard, will tell you more about it. They're actually part of Consensus, and Consensus is BUIDL network supporter as well. I'm sure that you are already familiar with Consensus. Other sponsors are Eternity Blockchain. That's not Ethereum, by the way, but they also do some pretty cool stuff. Grape Bikes, we have a representative of Grape here with Grape shirt. They are doing digitalized equity on blockchain, so you can ask him later all the questions if you need. And Node Factory, that's us. We build dApps, but lately we are more into infrastructure and tooling development, especially with E2, the new Ethereum proof of stake. So that's all. I have one news regarding this conference that will be held soon in Prague. We have only one ticket that we can give away free. So I decided that I should give the most active person in this group this ticket. So who asks the most questions to our speakers will get that free ticket. It's a nice conference in Prague. It has a really various topics that cover general blockchain and eternity, of course. So ask questions, not any question is dumb, so please just try to learn more, because that's why we're here for, sorry. So our first speaker today is Boris Stanić. He's a community manager in Raiden Network. That means that he posts memes on Reddit, but he's actually a software engineer. So please, big applause for him. He'll talk about Raiden Network and demo the clients.
This is always the hardest part. So, yes, but no. Think it. Okay, nice. So yeah, can you hear me? Can you all hear me good? Okay. Raiden Network is a layer 2 scaling solution for Ethereum. It's basically a payment channel network. So I'm not sure how much crowd has knowledge from before. So I was thinking about keeping this more or less basic, and then we'll just, you know, if somebody has more advanced questions, they can always ask, because not many people know about payment channels, what's even payment channel network, state channels, and scaling solutions. So let's start with a couple of questions. Does anybody know what's layer 2 scaling? What solutions are there? Okay, yeah, Belma, not you. So yeah, please, guy in the white shirt. Yeah, payment, plasma, state channels, and I think recently there were some mentions about some new concepts, roll-ups and snarks. Yeah, but for now there was no dummy explanation, so I don't know much about that. So we'll skip that. So yeah, plasma and state channels are like older concepts about layer 2 scaling. And whole concept of layer 2 scaling is that you don't need all the nodes confirming every transaction. You just need some of transactions confirmed, and those in between are, you know, confirmed in different way. And today we'll see how that works in Raiden network. So yeah, we can start a presentation. This is me. I'm Boris Stanić. I've been with Raiden since 2017. Project, I think, started at 2014, something like that, but it really got going in late 2017. And my daytime job, I'm a PHP developer. So yeah, old technology, new technology. I have to say, I'm not an official representative of Raiden. So whatever I say, it's not official. I can say whatever. So yeah, this is just a disclaimer. So yeah, motivation for now. Currently, Raiden chain is not Raiden, Ethereum chain is not that fast. So it can do tops, maybe 14, 15 transactions per second. I did this screenshot, it was doing 7, I think, on this screenshot. That's not too much. So for example, Visa can do 80,000 a second. And this is kind of a problem. So this problem was most recognized late 2017. Everybody remembers CryptoKitties. Yeah, Ethereum people started spawning some kittens. Nobody could use a chain anymore. And then a lot of people recognized we have a problem. Before that, it was like, maybe yes, maybe no, but CryptoKitties really proved us, okay, we have to do something. So why is it so slow? For example, if I want to do a transaction, all nodes in the world, mining, everything has to go do their job, and I'm just buying a coffee for $1. That doesn't make much sense, you know? So there are some tweets from important people recognizing this problem. For example, Vitalik recently said that, you know, why there is not more adoption from big players of the Ethereum. It can do 10 transactions per second. If somebody comes and they need 5, which, you know, 5 transactions per second is not that much, they will be competing with all the others, and price is just too high. It's currently not completely ready for that kind of volume, and we will try to solve that. Introduction to Raiden. Okay, one doge is always one doge. Raiden is a payment channel network. So, okay, let's start explaining payment and state channel networks. So state channel networks are more generalized. while payment channel is just sub-portion, it's derivative. That's probably not the best word, but I will explain it. So state channel networks can exchange between nodes anything that has a state, while payment channel networks only mostly work with numbers. So you can exchange balances between nodes. And Raiden is currently focusing only on the payment channels. So did I skip something? I hope not. Okay, yeah, this is a payment channel network. This slide should have been after the next one, but I'll explain. So these are all nodes, A, B, C, D, E, F, and between them there are some ERC20 tokens. And they can do payments between themselves without needing Ethereum chain. So no layer 1 included while they're doing payments. We'll later see when do you need Ethereum chain, but for direct payments, when channels are open and there are tokens inside of them, you don't need a chain. This is how a payment channel is created. So some transactions need to be confirmed on the layer 1. Layer 1 is Ethereum chain, if you didn't catch by now. I didn't say that explicitly. So opening a channel, closing a channel, topping up channel, and some actions need to be confirmed on the Ethereum chain. So this is an example where you open a channel. It's actually a smart contract where both parties agree and they deposit some amount of ERC20 tokens. And after that, you are sure that you have somewhere to claim tokens afterwards. So you can never trade more than there is inside the channel. Its max capacity is defined while opening a channel. It can be modified later. And we will see how exactly do you transfer tokens then once you deposited inside the smart contract with some other party. So how does Raiden work? You always have to place an on-chain deposit. Both parties do it. So for example, we have party A depositing 4 ERC20 tokens. Party B is depositing 2. Party B can send to A 2, and then maximal transaction that A can do is 6. So if B doesn't have any more tokens to transfer to A, it can't. It can only receive from A. So they're always exchanging what they have stored on the layer 1. Yeah, Raiden works with any ERC20 token. So how exactly does a transfer happens off-chain? So for example, if I have channel with the guy who mentioned plasma and state channels, and I have some tokens. If I want to send him amount of tokens, okay, I say, okay, here's one ERC20 token, and I will sign a balance proof where I confirm that these tokens are yours. And when he sends me some tokens back, then he uses his key to sign me balance proof, claiming that he confirms he transferred some tokens to me. So we don't need a chain. We just do communication between ourselves. So yeah, since we don't need a chain, we can do it without fees. And it's faster. It's basically as fast as a classic Web 2 HTTP request. So latency, so spoilers, we will do a demonstration, is pretty fast. And now the best part. For example, if me and him have a channel and he has a channel with somebody else in the crowd, I can say, okay, I will use your channel with that person to send that person some ERC20 tokens. And how that does happen? I send him 2 tokens, for example, and then he, in my name, sends to that person 2 tokens. At the end, I have 2 less, that person has 2 more, and he's at 0. Of course, there needs to be an incentive for this, so usually he will receive some kind of fee for doing that favor for me. But you know, it's not so expensive for him, so those fees are really minimal. We will later see how Raiden team envisioned fees and what problems there might be. Okay, so Raiden Network has been in hardcore development since late 2017. Team started growing, more developers, more activity. And in late 2018, December, Raiden had the first mainnet release called the Red Eyes. First mainnet release included some features such as opening a channel, sending transfer, closing a channel. It could do mediated transfers, but some services which are really needed were not included in that release. We'll talk about those services later and why the first release was called Red Eyes. So yeah, this is the QR where you can check the Red Eyes. So the next release, which should come relatively fast, and team is working on it, is called Alderaan. Alderaan is from Star Wars. Not a big fan, but I didn't have a vote. So yeah, it's called Alderaan. I'm sorry. What can you expect from Alderaan? So, there were some changes in plans. First big major release after Red Eyes was supposed to be called Ithaca, but plans changed a little, and plans about what development team is building expanded a little, and they decided to build a whole ecosystem, and one of the biggest focuses for 2019 is user experience and developer experience, because Raiden can be integrated in any other dApp for payments, of course. So they want to make it easy for developers to build on top of it and for end users to try it on. So yeah, some of the features of the Alderaan release will be the Raiden services, mediation fees, and new features such as partial withdrawal from the channel. What else? My mind stopped. Okay, let's say that's the only one, but it's not. I will remember. So the services, okay. First release of the Raiden didn't include 2 very important services. First service is pathfinding service. So example I gave before where I send mediated transfer, that's a transfer where we have a party between me and the receiver. It's pretty simple because path is quite obvious. If I have a direct channel with somebody and he has a direct channel with my target, it's pretty easy. But you see how it can easily get very complicated because channel networks can grow and maybe solution is not so easy and there should be, I don't know, 5, 6 hops. It's hard to know which is the correct path, and on top of that, that path needs to have enough ERC tokens so it has enough liquidity to execute that. And everything is changing in real time. So this is like hell for pathfinding algorithms. But Raiden team is working on a pathfinding service which you can use. You pay a little fee and you say, hey, pathfinding service, I want to send payment to this person, and you will just get what hops you need to do. You do a little fee, payment, and you just follow the path, and that payment will be successful, hopefully. Of course, there are some chances of situation changing drastically in the meantime, but success rate is quite high. Second service, which is really important, is the monitoring service. And what monitoring service does. So when I do a payment to another party, I sign him a balance proof saying, okay, I confirm that I sent you some tokens, and other party does that in return when they send me payments. And when we want to close a channel, we both submit our balance proofs to the smart contract, and smart contract determines which is the later version. Hopefully we both submit the same version, but it always chooses the later one, and then splits funds that were inside the smart contract on chain, how balance proof state that situation is. So if we had both 5, then I sent all 3 and 2 more. So I should end up when the channel is closed with 0 on the layer 1. If we submit the balance proofs, I get 0, my party gets 10, and that's it. But here's a problem. Smart contract doesn't know which is the latest version. It's always kept between us. So if you want to cheat someone, you wait until it's dark and he's offline, and you request to close the channel. Of course, there is some buffer in blocks amount, so usually 500 blocks, something like that, until that person has time to submit their balance proof. But let's say they are hard sleeping, so no time, they don't notice. You submit an older balance proof, which is more in favor for you, and then you end up with more tokens than you should have. Well, in Redeyes, that was a possibility because there wasn't a monitoring service. What monitoring service does, on each update of a channel between 2 parties, it saves the balance proof to help you, and if it notices that you are offline and unable to submit the balance proof for channel closing, it will do that instead of you for a small fee, of course. So these 2 services, monitoring services, which make sure that you don't end up being scammed, and pathfinding service that helps you find a route inside the network, are the most important features of the Alderaan release. Optional mediation fees. Okay, yeah, that's pretty interesting. So we noticed that if 2 parties have both 5 tokens between them, and there's a chance that you will end up with 0 tokens, and other party will have 10, and you don't have any more tokens to do payments with. Then it's really beneficial if somebody does a mediated transfer over you, so you receive some tokens back. And optional mediation fees will do different fees depending if mediating that transfer is beneficial for your channel, or is it making situation even worse. So that's a little bit more advanced topic, and if anybody has more questions, we can do that while the Q&A. So yeah, this is explanation of the monitoring and pathfinding service. RSB registry, it's just a registry with the service providers of the monitoring and pathfinding service. Mediation fees are not mandatory. You can be, good Samaritan and do mediation payments free of charge, but I'm not sure if everybody has such a big cart. So there's an option to do a little fee. So yeah, this is the part I was explaining. The flat fee, you can set up a flat fee saying, okay, I want 0.001 of this ERC20 tokens whenever I do a mediation transfer over my channel, and I want the proportional part depending if this mediating payment is good for my channel. You always want to have it balanced. You want to have enough tokens in all your channels so you can always do some kind of payments. If you run out of tokens inside of one of your channels, you have to wait or top up. So you always want to have it well balanced. So depending on how balanced it is will depend your proportional fee. Channel withdraw, in the red eyes, there wasn't a channel withdraw. So if you wanted, for example, some tokens on layer 1, so you can use it again, you had to close the channel. With the Alderaan release, you will be able to say, okay, I have 100, I want 20 on Ethereum chain, keep the 80. So this will be really nice. Development team is working really hard, so people don't need to know what I'm talking about. So you don't even have to worry what's a mediated transfer, how does it find the path, is it connected to the monitoring service. They want to make a nice abstract layer where you can use it like, I don't know, any other bank app or something. You just open, send some ERC20 tokens, and don't worry about anything. This is the user experience part. Light client. Light client, I will showcase it. I hope if we have time. So you can run the full node that has access to the Ethereum chain, is reading updates and is online. And then there is a light client which can be ran inside any web-free browser. Okay, question? Yeah? 5 minutes. I think I'm done soon. So yeah, I'll showcase light client, no need to explain. Raiden Wizard is a nice, friendly way in which you can install Raiden with just running one command. It does everything. Opens a channel, mints some tokens on the testnet, gets some ERC20 tokens, everything. So here's a short demonstration of the wizard in a GIF. Yes, I'm that person. No, it's a GIF. So this is a little bit sped up, but this is essentially how it's done. Closing remarks. Awesome Raiden. It's a GitHub repository. You can find everything about Raiden there. My colleague and good friend, Matthias, has been collecting everything about Raiden since 2016 and was adding it to this GitHub repository. And you have everything from setting up a node, opening channels, talks, presentations, everything. Little recap. So Alderaan will be a mainnet release. Light client is a focus because team recognizes that majority of users will be using only a light client. And improving user experience and developer experience with tools such as Raiden Wizard and the Web UI, which I will showcase. So yeah, thank you. You can follow Raiden on their Twitter. Interesting Medium articles come regularly on the Medium. And you can follow me on Twitter. It's here. And this is a Telegram group. It's an unofficial, but really interesting questions and discussions are always ongoing. And it's kept unofficial, so whatever topic you want to discuss is open. And now, let's do a little presentation. This will be a little more fun. This is not good. Okay, maybe if I do it's still huge. This won't look good. Yeah. Just okay. Can be better. So it's not perfect, but it's visible what's the most important. So I have 3 nodes running on my machine. Each of the node is using Infura. Are you guys familiar with Infura? Okay, so it provides me data from the chain, and it's on 3 different addresses, and I didn't want you guys waiting, so I opened the channel between 2 nodes, topped it up, and now it's ready for doing payments. This is the web UI the Raiden team is working. I think it looks pretty nice. So you can see an address. I have 4 channels. I'm a part of VETH token network. So first you join a token network, and then you create channels with other members of that token network. Question, maybe, why do we have to use ETH and we can't use ETH? Because ETH is not an ERC20 token. It's not supported with Raiden. So it has to be wrapped. To get ETH, it's basically a smart contract. You send ETH to it, and it issues this ETH tokens. And if you want back your ETH, you send ETH, you get ETH. So it just wraps it into an ERC20 token. Now let's see how fast are those payments. This is the most interesting part. So, okay, a little bit of late messages. I have this node, 3.8, and C94. Let's send some payments to the C94 if I can. Should be able to. Don't see it. Because probably it doesn't show the full. Maybe this one. Yeah, it must be this one. So receiver address. I have some channel, some width inside. Let's not give too much. This is all on the testnet, so on Kovan testnet. So if I send, that is it. So basically, transaction is final. You are sure that you will be able to claim what I just sent eventually once you close the channel. So yeah, 0 fees, 2 seconds, and payment was done. That's a short demonstration. Let's save 10 minutes for Q&A, and if there won't be too much questions, we can check the light client. So anybody has any questions? Oh my God, the hardest question. No, there is no official release date for the Alderaan. I do, as a community helper, updates on the development each week, and I think it should be pretty fast. They are closer than ever. But no, it won't be years, that's for sure. Currently, what do you mean? What by it is? Yes, but in 2014, it was just one guy presenting this as a concept during the DEPCON, no, the zero, DEPCON 0, yeah. So then it started, I counted this, but real development really started in late 2017. Yeah, a year and a half. But you know, blockchain space, everything is always, it's a R&D essentially. It was never done before. There's a lot of research, and it takes time and effort. So yeah. Any other simpler questions? Yes, please.
So that's service registry, pathfinding, your helper. How decentralized are the services?
So exact specification how one will become a service provider were not yet released, but it's mentioned that anybody will be able to become a service provider. And another point, for example, for the pathfinding service, this implementation that Raiden team is doing is just a suggestion. If any of you guys come up with the more efficient pathfinding algorithm that you can use in a Raiden network, once you become a provider, you can basically use your own code to provide such service. Same goes with the monitoring service. If you find a more efficient way where you don't have to keep every balance update and you are sure that you will be able to provide the correct one to the smart contract, it's free to implement your own solution and provide your service. No, it's basically Lightning for Ethereum. Yes, they don't have external pathfinders. They only have watchtowers, which are essentially the monitoring service. They call their monitoring service watchtowers, and pathfinding is done internally inside the node. Yes, like pathfinding inside the payment channel network is really hard, because if you do some kind of calculation, some payment goes, it changes the liquidity inside the channel, and your solution is wrong. So it will be really interesting to see, once payment channel networks grow, how many hops and with what percentage of success those paths will be. Any more questions? Yes? Transactions per second. Now that's a good question. So theoretically, they are infinite, because you can do with one party between you to as fast as your internet goes, and everybody can do between themselves just transactions. So inside the channel network, it's basically infinite. Yes, once you are closing the channel. That's a simple call to the smart contract. It's a single transaction. You just call the channel settle or channel close, and once it goes through, it settles the channel, divides what it had inside in the correct way, and that's it. It's just a single transaction on chain. So there is no need for some performance test for that. Yes, there were more questions. Okay, back, then front.
Some community are not fan of payment and stations. I've heard you say it's mathematically proved that it will not work with cops and everything. What's your response to that?
Yes, so
Jump on the payment channel solution.
So yeah, the biggest problem is liquidity between nodes, and this pathfinding problem. But for example, if you do regular transactions with one party, you just open a channel inside Raiden, and you do transactions between you two or maybe some other party, this will always work, because critics always think of moving millions over this most criticism was for the Lightning Network. You can't move more than 1 Bitcoin, but it's not made to move more than, I don't know, $10. This is for microtransactions, I buy a coffee, stuff like that. It's not meant for the big transactions. It's exactly to avoid need for all the confirmation mining fees for the small transactions. This is what it's targeting. So did I answer your question? It's basically people that say that it won't work are thinking about big transactions, and it's recommended to do one-off big transactions on main chain, because you won't go through hassle of opening a channel, topping it up, etc for just one transaction. But for smaller regular ones, I think it will be great.
So you think the claim, the math behind payment channel stations is not good?
Well, it will definitely work. You know, it just depends what math. I think you are referring maybe that 70% transactions bigger than 0.1 Bitcoin with 5 more hops are failing. Okay, if you need that kind of thing, just open a direct channel, and you know, connect yourself a little smarter, they will probably be always hubs. So you can always connect to some big hub. What hub means. I'm connected to the hub, and most of your other targets are connected to a hub, and then it's basically a one-hop transfer. So it's pushing the technology to the limit which it just is not targeting with. So yeah, I don't think that criticism is too valid. Yes, I think he raised his hand first.
You actually answered my question with the hubs, because I was wondering if I'm making a channel only between myself and another partner, I can open as much channels as I want with the other partners, and how am I going to, I don't know, make a micropayment for the coffee in a Starbucks or something like that if I'm not directly connected to this store or something like that. But if store is connected to the hub and I am, so
Yes.
much resolves the question.
Yes, there are some other payment channel solutions in the Ethereum space, and they mostly target only hubs. Raiden is the, I think, as far as I know, only one which is not targeting hub, but it's you know, essentially you can do mediated transfers if there is enough liquidity with I don't know, 100, 200 nodes between. So, but some of thinking is that hubs will form naturally. So just, you know, if you let payment channel to do its thing, hubs will form because people will be connecting to channels and nodes with a lot of liquidity, and they will form. But it supports technology without hubs. It's essentially, there are no hubs in the core idea of the Raiden. Yes, please.
So Raiden Network has its own token.
Yes, you are correct.
Expand on how it's used.
Okay, Raiden Network Token, RDN, it will be used for paying service fees. So you will pay pathfinding service and monitoring service in Raiden Network Token. There will be probably more uses for the token, but some usual misconceptions. You don't need to stake RDN inside the channel. If you don't want to use services, you can just join the network without RDN. So these are some usual misconceptions that go over the internet. Any more questions? Yes.
If I don't use pathfinding service, what is the way for me to find the path for the payment?
So you can do some kind of your own solution for pathfinding.
That's true, but how am I going to know which nodes are interconnected?
Maybe you don't even want to, you know, do any mediated transfers. You want to only use.
I just want to make myself pathfinding service. So I'm interested to find all the possible pairs in the network that I can use to make transfer through the nodes to the party I'm interested in.
I don't think you will be able to. So you will need.
So yeah, I'm actually forced to use pathfinding service provided by the Raiden network because there is no solution or any other way for me to find the path for my payment by myself.
You can use some kind of internal routing, but that mostly depends on you. You can I don't know, you can try to send a payment with some internal routing, saying this payment needs to be mediated in this way, but with pathfinding service, you have more chances of success.
Okay, I'm aware of that because every node is registered in pathfinding service, every pair is registered, and I
Yes. Yes, you can see inside the smart contract all the. That's how it basically some of the explorers of the Raiden network. There's Explorer where you can click over the nodes, knows which paths are there. So it's all recorded inside the smart contract. Yes, you can, of course, do your own path finding, but if you want somebody who's always online, knows the updates of capacities, there's a fee. Any more questions? No. And do I show a light client? No. I'm sorry. Okay, thank you all for questions. Yeah. This was the Raiden network.
Thank you, Boris, and thank you all for the questions. I'm not sure if you are heating up the game for the conference ticket or you're just curious about Raiden network, but keep going. I'm keeping the count. Yeah, you slow down. You have too many questions now. I'm just kidding. So that's all good. So our next speaker is Bernhard Mueller, and he is a security software specialist that has a long track record in web apps, operating systems, software protocols, and so on. Sometimes an award winner in the security space. He's speaker at DevCon, DebCon, and other cons. Now BUIDL. So please big applause for him. And he came in yesterday from Berlin. So thank you.
So this talk is actually from DevCon with an F, which happened last month in Las Vegas. And I'm now kind of, sorry. Morphing this into another talk for DevCon with a V, which is for Ethereum developers. So it's kind of really, really targeted on Ethereum developers that know Solidity and EVM. So how many of you actually write smart contracts? Oh, cool, quite a few, that's awesome. So I'm gonna talk about a couple of tools on general principles in this talk. The first one is MythX, which is an open source analyzer that has been around for a couple of years and was initially developed by me, but is now maintained by Consensus. And the second part is about a couple of new tools that we have released, including a smart contract verification API, with the goal of making it easy to detect bugs in smart contracts like in CI and development environments, and make it really straightforward for developers to avoid stupid bugs. So first of all, I will give a bit of background on what MythX does. So we use a technique called symbolic execution to detect bugs. And that means if you look at this very simple contract, for instance, so this is a smart contract that represents a cat. And there's one function that may either extend the life of the cat or kill it. Right, so and if it kills it, then the contract self-destructs. And self-destruct is a really interesting instruction in Solidity. So what it does, it destroys the contract accounts and withdraws the funds to some address that you specify here in this argument. So and normally when I execute this contract, there's two different ways it can go. So either I make this variable true, which means nothing will happen, or I make it false, and the contract will die, right? And that's called a concrete execution. So all the variables have some specific value. And now in symbolic execution, what we do is we have a special implementation of the Ethereum virtual machine, and we execute always both paths. So if there's a conditional jump, we go down both directions, and we make note of the path conditions on each path, and we build this little propositional formulas that tell us how to get to each of these points in the contract. And the awesome thing about this is now that I can, at any point, so let's say I come here in my analysis, I can compute how to get there. So I can say, I just solve this formula here, and I know what input variables I have to send to kill the cat, right? And this can be arbitrarily complex. So if a huge contract with many ifs and so on, I can always compute that. And I can determine, for instance, if it's possible to kill that contract or not. So there was an incident in 2017, if you've been around, in a parity multisig wallet, where there was an exposed kill function. And I think $150 million worth of ether becomes stuck because somebody accidentally called the function. So I have a demo here for MythX detecting this. So you can install MythX. It's open source and free from Pipey. So basically, it's just a pip3 install MythX, and then you use myth analyze. And that's a little bit simplified version of the library, because otherwise the analysis takes quite long. So that should finish in a minute or so, I hope. So in the meantime, look at some more slides. So there's a lot of challenges in detecting results in a way that they're useful for developers. So for instance, you only want to return results that are actually exploitable in practice. And so this is another example from a real world contract that was exploited called beauty chain. And the vulnerable function was called batch transfer. So can anybody tell what's wrong with that contract? Why would that be a problem here, this multiplication? So what this function does is it transfers multiple, it does a batch transfers of multiple transfers of a token from one address to another address. And that was added basically to the standard functions in the ERC20 contract. Right. So like every uint256 can only hold up to 256-bit large numbers, right? So 2 to the power of 256. And here if you say, I want to transfer a large number of tokens at a large value, this amount might overflow and might become a very low number. So essentially what you can do is you can make this exactly 0, and then you can transfer a very large number of tokens to yourself without actually subtracting any tokens, because amount is 0. And people use this obviously to create like billions of tokens for themselves and withdraw them from the exchange. And so you can detect things like this with symbolic execution quite easily, but it's not that trivial, because there's a lot of instances of integer overflows that might actually happen intentionally. So in OpenZeppelin safe math, for example, you have this code, and this adds 2 numbers in a safe way so that no overflow can happen. But what happens here is that the overflow actually does happen, and it gets checked afterwards that it does happen. So if you have a naive tool, it might still report something here. So, and there are a few tricks that we've implemented to know what integer overflows should be reported and what not. And I can show you that as well. Okay, so that's the result from Wallet library. So let's look at the code here. That's very similar to what happened in the parity exploit. So we have here the kill function, and only the owner can kill the contract, right? And then here we have a function called initWallet. And the problem in this case was that since it was used as a library, nobody had ever called this function. So it was basically open to still be initialized by anybody. And as soon as you call this function, you make yourself the owner, and then you have the right to kill the contract. And that's what happened. And Mithril will tell you exactly that. So it will detect that anybody can kill this contract and withdraw its balance. And you need to send exactly these two transactions to do it. So you need to send initWallet. This will make you the owner, and then you send kill, and then the contract is dead. So for BUIDL chain, that's the algorithm. I'm not gonna go into that in detail. I can also show you the demo here. Mithril analyze. And this command actually is so that runs a default analysis and checks for a number of things. And the default settings are pretty good, so you can detect it's very reasonable set so that it won't run too long, but it will detect the most important issues. But if you look at the on the command line flags that are available, there's actually a lot you can fine tune if you know how to, and that becomes important once you really want to verify security properties and want to have guarantees that something doesn't break. But just for the generic stuff, this is quite an okay way to do it. So the output of this will be, hopefully, exactly this function. And it will also tell you, I think, the exact number you have to send to overflow to 0. And notice that this will increase your token balance. Another thing I've shown on DEFCON is that you can take this output from Mithril and automatically convert it into an exploit. So you can have another tool that then sends these transactions to the blockchain. And people are doing that, obviously. So, okay, that's not finished yet. Okay, so another challenge in symbolic execution is state space explosion, which means that if you have a lot of functions that modify the state, like each transaction that you go down, executing symbolically, you have to consider all the possible end states that might happen after the first transaction. And so the space of states grows exponentially. And then like if you go to 3 or 4 transactions, it becomes huge. And you need a lot of computing power to actually deal with that. Can show you a typical state space graph. So it looks like this. So let's say execution starts here at the first instruction, and then you have a couple of possibilities where you can go, depending on the call data, and so on. And so this runs through the whole first transaction. And then at some point you will reach the end of the transaction. And then it will start the second transaction again from 0 with the new state, right? And you can easily see that after 2 or 3 transactions, this becomes this huge tree of stuff that you have to look at. So we have had some improvements there as well, where we look at interdependencies between states and at whether modification in TX1 are actually relevant for some blocks here. And so we can really make this a lot faster. So if you look at the benchmarks, the speed up compounds really nicely. And with 3 or 4 transactions, we have over 400% speed up, which is pretty cool if you want to do like formal proofs and get like a higher confidence on the results. All right, so that was the hardcore technical stuff. Now to move on to some tips for smart contract coding and how you can use tools to help make more secure smart contracts. The first most important thing is to keep it as simple as possible. So everything that you deploy to the chain is supposed to be immutable, and you're supposed to get it right the first time to deploy it. And for that to happen, it needs to be simple enough so that you can fully understand and consider every possible attack vector that could happen, right? So Ethereum smart contracts are not supposed to be like huge web browsers or something with a lot of libraries and updatable. They're supposed to be small and simple. And you should know exactly how the code is supposed to behave. So you should have specifications that say, okay, this can happen, and this should never happen, etc., etc., and a threat model detailing how different actors might be able to exploit the contract and what you're doing against it. And if you have these detailed specifications, then you can use tools to prove that your contract also behaves according to them. And it's always good to have a security expert on the team, even like from the start of development, because mistakes that you make early on in the design get exponentially harder to fix at the end, right? So if the auditor comes in, like you want to deploy in a week, and suddenly the auditor tells you everything is completely broken, you have to rewrite the code, then that's very costly, and you can avoid it by just starting that process early on. So tools can't replace audits and human expertise completely, but if you use them correctly, they can do a couple of things. They can help you detect generic bugs, like some of those that I showed you before, integer overflows, bad authorization code. Very easily, you can build them into CI just to make sure that you don't do anything really stupid. And they can also verify contract behavior. A couple of things we do to do that is symbolic execution, which I just showed you, and input fuzzing. And input fuzzing is useful for more complex setups where due to the state space explosion I showed you before, the symbolic execution technique is not feasible anymore. So there you just throw random stuff at the system and see if anything breaks. So there's one resource I would like to show you, which is the SWC registry. And that's a list of these common bugs that you should avoid. And each of those has a description and also a remediation guidance and a few examples that show either like positive or negative examples. And we actually wrote all of this before we started writing any tools, because we wanted to have this kind of standards that people are supposed to follow. And we also needed like contracts to benchmark against. And if you think about it, for things like integer overflows, there are a lot of edge cases. So there might be things that can be relevant and things that cannot be relevant. So we need to know exactly when the tool should return what kind of result and what kind of severity rating. So to our API. So for the API, it's called MythX, and what it basically does, it accepts Solidity source code and bytecode, and it runs it through a variety of tools that we have built, including Mithril, but also our fuzzer and a static analyzer and some post-processing, and it just tries to find all the low-hanging fruit. So that makes it easy to use it in the CI pipeline or just with a command line tool. And the goal of this was to make it super easy for developers to use. So we really focused on integrating with popular environments like Remix and Truffle and just make it work out of the box. So you click a button and it works, because yeah, that's what people like. Okay, so I think for the rest of the talk, I'm just going to show you examples that hopefully work. Okay, so another very important recommendation for me is if you want to learn about smart contract security, you should try these challenge sites. There's a couple of them that are very good. One is called Capture the Ether, and the other is called Ethernaut. And these have a series of levels that you can solve, and each of these levels has a security vulnerability built in. And these sites will actually deploy a vulnerable instance of the contract to a testnet and let them try to exploit it, and you get points for solving them. So that's super cool. And I always love to use those contracts as examples to show off. So this is one from Capture the Ether. And the goal in this challenge is to steal the ether from the contract. So here's some code that transfers 2 ether to you. And this is based on guessing a random number on the blockchain. So what do you guys think? Is there any way of exploiting this? Is it too small or? It's better? Huh? Right, that's one thing you can do, I guess. Well, let's see. It gets constructed here. Right, yeah.
How much time, how long it's going to take you to send the answer and try it. But you need to be fast.
That's another question, yeah.
Or you need to find slow network to do it.
Yeah, that goes into another thing actually, but you're right. You could just calculate this number by yourself because the block hash of the last block is known. So you have 20 seconds, right? Or even like. Yeah, but it's not a big deal. But on the other hand, so you have here a private variable that contains the answer. And private variable in Solidity doesn't mean that you cannot read it because it's still on the blockchain, right? So so all you have to do is to read the answer from the blockchain and send the right answer. You can just use MythX, for example. It has a flag to say read storage. And these variables, they are always mapped to storage indices in the number that are in the order that they are defined. So this would be index 0, and if you just read 0, then you will get the answer. But there's another problem. So if you now try to exploit this, then it will not work. But that's because there are a lot of other people monitoring the blockchain, and they will see you trying to do that, and they will quickly try to get a transaction in before you. So those are bots, and they will simulate all the transactions coming in. And if you know how Ethereum works, then you know that miners select transactions based on gas price, right? So if I send a transaction trying to steal this ether with a gas price of 10, then there will be a bot seeing that, and the bot will know this is profitable for me, and it will send the same transaction with its own address, but with one way more gas price. And then this transaction will be included first in the block, and I will get nothing. And I will in fact lose 1 ether because it requires me here to put in 1 ether, right? And this goes over multiple levels. So there are many people who intentionally deploy concept like this and wait for people to attack them, but then they actually steal the ether from the people attacking them. and then maybe even that may fail because there's another bot, and it's kind of like this war going on, which is really funny. So we did a CTF on DEF CON, and we actually didn't think about those bots, so we put up a few challenges, and the people who were supposed to win the challenges actually didn't get the ether because the bots stole the ether first. Oh yeah, so now with MythX, we have this plugin here. So if you go to Remix, you should find this in the extensions list. I already activated it. And then if you can compile the contract, you just hit analyze, and then you will get these results here. And it will, yeah, at the moment, the user interface is not reacting for some reason, but it should point out like the locations in the code. Right. Let me try again. Guess the random number. Compile it. And now analyze it. Okay. So now you get yeah, all this weak randomness, and it will also tell you that anybody can withdraw the ETH from the contract. And so in this user interface, you actually don't see the transactions you need to send, but with some of our command line client, it can output that as well. I'm going to show you that too. So here's another example from Ethernaut. It's one of the challenges. Again, the goal is to steal the ether, I think, yeah. Can anybody see a problem there? I make it a bit bigger. You guys know how a Solidity constructor used to work like in Solidity 4.x. Okay, so in older versions of Solidity, what you could do would be to have a constructor by having a function that has exactly the same name as the contract itself. But if you look closely here, the name is actually a little bit different. So there's a 1 in here. So this function is actually not a constructor, but it ends up in the runtime code of the bytecode, which means that anybody can take over this contract. And if you take it over, then you are the owner, and you can basically do this, and it will send you the complete balance of the contract. And I think both Saber and, I didn't tell you about Saber yet. So besides the Remix integration, there's a whole lot of other tools. And our idea was to provide the basic security analysis API, but let others build tools on top of them, because we thought it would be difficult for us to build all the integrations ourselves. And if you build a tool and the tool is successful, and so we have a subscription system where people can purchase license plans to use the API with DAI. And if your tool gets usage by paid users, you will distribute some of that revenue back to the tool developers. So right now we have a few partners, including Belma and Node Factory, who have come up with a couple of awesome tools. Yeah, the main ones being used right now are Remix, Truffle, Visual Studio Code, Embark, This is one of the tools from Node Factory, which is hopefully going to be released soon, which will be a GitHub app for CI. We also have libraries to make development on top of the API easier. And we also have command line tools, and I'm going to show you this one right now. It's called Saber, and I wrote this one myself. It's kind of experimental, but there was no other tool in the beginning, so this is really super easy to use. You just install Saber MythX. You can also set up a MythX free API account. So you go to a website, you get the API key, and you put it into your environment. But it also has a built-in trial user to try it out. Okay, and this hopefully handles all the compilation stuff automatically. And this will also detect here that anybody can withdraw all the ETH from the account. And it also tells you the transactions to get there. So here's the fallout, the misnamed constructor. That's the first thing to call. And the second one is this function. And then you will effectively steal all the funds from the contract. Okay, so Truffle integration. Truffle is a very popular development framework. Who of you has used it already? So with Truffle, it works the following way. You install a Truffle plugin. So that's a typical Truffle project with a contracts directory and a Truffle.js. Okay, just gonna skip that because actually I already installed it. And then you get an additional Truffle command that says Truffle run verify. And that should submit all your contracts to the API, assuming that they are compilable. So it will just use whatever Truffle produces, all the compiler artifacts, and submit that. And that makes it easier for us to actually know how to compile your project. Because if you have a huge project with hundreds of contracts and NPM modules and dependencies, then it can be quite challenging to do that. So it's much easier to somehow build the MythX analysis into the build pipeline at a moment where it's already being built successfully. And that's what we do here. And we also have a dashboard. And this should show you all the analysis you submitted. So here you get a pretty nice report with all the results. Yeah, no, not much in there. I would have expected to find some more there, but I know, something, demonstration effect. Right, but the results here are correct. So we have this reentrancy demo, and that's actually a variant of the DAO. So it demonstrates a reentrancy flaw. Everybody familiar with the DAO hack? So that was the first big, super big incident that led to the hard fork to Ethereum Classic, where I don't know, 10% of the Ether supply was stolen from a DAO smart contract. And that was caused by a vulnerability type called reentrancy. And so the problem is here in this function. So if you look here, I can withdraw from my balance. And this withdrawal triggers a call to my address that sends the Ether. And then after this, the amount I withdrew is subtracted from my balance. But actually, if you know how these low-level calls work, is that it sends all the gas with the transaction to your own contract. So if this is a contract address, what you can do is you can call back into that contract, and you can call withdraw over and over again. And because the amount is subtracted only here, it will never get subtracted. So you will always have the same balance. And you can do this infinitely until the gas limit. And yeah, that's what people did. And MythX can detect this kind of anti-pattern as well. So yeah, I think we're pretty confident at this point that we have learned about most of the common flaws, and we can now detect them with tools. So we think that we can prevent things like DAO and parity. It's pretty unlikely that it is gonna happen again, because there's just a lot more awareness now and a lot more good tooling to deal with this kind of flaws, which is reassuring. Okay, so finally, if you still have time, I'm going to talk about writing custom tests. So what I've shown you now are just generic bug detection techniques, where I know, well, if anybody can kill your contract, it's most likely not a good thing that you want to have in your contract. But a lot of things are actually dependable on business logic. And because tools don't out of the box know how your contract is supposed to work, you have to write custom tests that verify some of the properties you think your contract should hold. And this is a very simple example here. Let's say you have implemented a bank, and the bank allows users to deposit and withdraw funds. It also has a refund function and some helper functions. So like, you can now make the assumption that if this bank starts with a balance of 10 Ether and everything works as expected, then the total balance of the bank should never drop below 10 Ether, right? Because no user is supposed to withdraw more than they paid in. So you can put this into an assertion. The solidity assert statement checks if a statement holds, and if not, it throws an exception. And MythWill and MythX will detect that exception and will tell you why it occurred. So that might be too small for you to see, but there's a little problem in this bank contract as well. Anybody spot it? Okay, so that's good, right? Because so now the tool can tell us that there's actually a problem. And you can do this either with MythX or with MythWill. So in MythX, in the premium package, we also have a full mode that runs the symbolic analyzer and fuzzer for a full 30 minutes. And that's very likely to find bugs that are a little bit deeper within the contract. But it's still not a correctness guarantee, because it basically means that we run our tools for a certain time and we try to find a counterexample to your assertion, but it might be that the time is just not enough for the tools to find it. So if you really want to do like a formal verification type of thing, you still have to use one of our open source tools and you have to know exactly how to use them. But it's still a pretty good thing to do. And yeah, so I'm not gonna show that now, but if you run Mithril on this here, it will detect one violation. I'd like to get rid of this here. Okay, now it's gone. All right. So it will tell you if you call this specific sequence of functions, then you will get out more ether than you put in. And it will actually fail the assertion and the balance of the contract will drop below. And the reason for that is that the refund function doesn't actually subtract anything from the sender's balance, right? So if you just call refund over and over again, or you call refund and then withdraw, then you can drain all the funds from the contract. So this is the kind of, I mean, it's a simple example, but you can imagine that for more complex smart contracts, you could easily overlook something like that, right? And then it's useful to have this kind of verification. So if you are in smart contract development, then please try all our tools. As I mentioned, Mithril is open source. You can find it on our GitHub repo or just install it with Pipey. And the MythX website is here. And there's also the awesome MythX tools page, which is a good starting point. Right, so it's called Awesome MythX Smart Contract Security Tools. And that was all the content. So any questions on it? Yes?
I was going to ask you, how do you actually run the solidity analyzing? Do you have some kind of a solidity engine which actually runs the old contracts line by line and analyzes
Yes.
mistakes? Okay.
Yes. So we run the constructor. So basically we have different tools. We have a static analyzer that just takes the solidity code and translates it into an intermediate representation and does some data flow analysis. And then we have a fuzzer. And the fuzzer can deploy the contract as it gets deployed on the blockchain. And then it starts from this initial state. And for the symbolic analyzer, we also run the constructor. But we are thinking actually about introducing another service where we have kind of a sandbox where people would deploy the contracts themselves, because that would be an even more realistic setup, right? And yeah, so at the moment with the API, we don't simulate contracts calling each other. So if you have a setup with a lot of contracts that depend on each other, that's not a very good analysis because we overlook a lot of stuff. Yes.
For example, in bank example, if it falls below 10, it doesn't need to go further. Does it make something like that?
Yeah, in a way you could speed it up, but it's more a way of like making it more specific, right? It's just testing for more specific things that you would like. But you could use it indirectly to speed things up, because most tools will just cut off a branch if they see that it's not viable. So if you ever require and you set some kind of conditions, then you will save a lot of path that the analyzer doesn't have to go down. Yeah.
So mithril is a floating character or something?
Yeah, there's actually a story behind that. So it was initially called mithril because Ethereum is also like ether is also a mystical material, and we thought like only a sword made of mithril can break the chain made of ether. And then, so we had mithril, the open source tool, which was fine, but then we wanted to create a commercial tool called Mithril Platform. And then we got a cease and desist letter from the Tolkien Foundation, actually, and they didn't let us get the trademark. So, yeah, so we had to rebrand it to MythX. Otherwise, it would still be called Mithril.
So basically you're trying to solve an NP card problem with analyzing the, I don't know, arbitrary programs. So what you're doing is sort of heuristics upon the knowledge that you already have, and do basically your best try with the knowledge that you already do. How well does it perform with non-trivial contracts? How much time do you need to analyze in order to get some I don't know, useful results?
Yeah, honestly, so one good thing is that smart contracts generally are not that complex compared to traditional like fat desktop applications or web browsers or things. So it's like a completely different level. You can cover a reasonable amount of ground with little resources. Plus you have restrictions on how far a transaction can run because of the gas limit. So you always know that execution of one transaction terminates, which is also an advantage. So you can confidently cover possibilities to a certain bound. Yeah, but just running the tools generically at very complex systems, of course, doesn't give very awesome results, that's for sure. So like if you have a very complex system, we have this enterprise service kind of thing where we look at the results and then we just try to build custom models and custom assertions and build tests around it, and we run longer fuzzing campaigns that are not possible through the API itself. So yeah, have to be pragmatic and
how do you handle some situations which are in code possible but in real life are impossible? For example, overflowing something that is maybe keeping the track of ether inside a contract. We all know that you could theoretically overflow it, but there's not enough ether to do so.
yeah.
How
So
do you handle situations like that?
also on multiple levels, I think. So we have certain heuristics how we decide if an integer overflow is relevant or not, but in the end it might turn out not to be relevant. So even if you overflow a variable and it ends up in storage and it changes control flow, it might still not be a vulnerability. But on the other hand, like if you can be very confident that something is a vulnerability, like withdrawing a lot of ether, then you can find other stuff indirectly. Like Mithril, for example, is capable of seeing like if there are 4 specific transactions that cause you to get ether, that there's an integer overflow somewhere in the way, and will also compute the exact value for the integer overflow. Yeah, but you're right, there are things that turn out not to be relevant in practice, yeah. Okay, thank you.
So everyone, you know the drill. Pizzas are outside, beers as well. So please stay and just hang along. If we eat everything and drink everything, which I doubt, we can move to the cafe downstairs. Yeah, please enjoy. And thank you all for coming. See you next time in maybe less than 2 months. So thank you, everyone.